Hey everyone, welcome back to another episode of Virtual MOSI. My name is Jose and this is our space series. Now today we're actually going to talk about stars, star formation, the stellar life cycle, and we're going to see how that ties into our very own solar system. Now if you've been watching our whole space series, this will hopefully kind of give you a better understanding of everything that's going on behind the scenes with our planetary dance, with the order of the planets and the gravity and all these things, because it is all tied together. Now, behind me I've got some materials here which were provided by the NICE network. And again, NICE is a pretty nice organization. It's called the National Informal STEM Education Network. And essentially they are devoted to providing educators with the right tools and materials in order to help facilitate science demonstrations so that you guys can kind of see the science a little bit better. Now, one of the things that we're going to talk about first is actually how stars form and, well, what a star is in the first place. So a star is really a very, very massive ball of gases, mostly hydrogen with a little bit of helium, and they're constantly going through a process called nuclear fusion. That means that at the very, very heart of a star, the pressure and the temperature is so high that it actually ignites. And when it ignites, it causes a chain reaction that gives off a lot of energy, and it's energy that's viewed all across the electromagnetic spectrum. That means that you can go outside at night and look up, and you can see the stars in visible light. But of course, the sun is also a star, so you can also walk outside in just a few minutes and feel the warmth of the sun because of ultraviolet and infrared radiation. And NASA scientists also use different telescopes, like X-ray telescopes and radio telescopes, to better study distant galaxies and faraway stars. So that's really what a star is, and now let's talk about how a star gets to be. So I've got this demonstration right here, and I have this hourglass, the sand timer, which will come into play in just a little bit, but let's actually visualize what this is. So in here, inside this wire basket, are actually some assorted styrofoam balls, and the wire basket itself represents the space, if you will, and these styrofoam balls represent different types of matter that are up there in space. Because you might think space is totally empty, devoid of anything, but that's not entirely true. There is actually still matter up in space, and it could be different gases, different dust particles, and what we're going to do is we're actually going to cause some turbulence by using this hairdryer to see if we can't get these particles moving around and clumping together. So I'm going to start this 30-second timer here, and we're going to see what we can accomplish in that time. So ready? Here we go. So 30 seconds. You'll see that I have some turbulence going on. I have the particles that are kind of trying to jump into the cup here, and that means that those particles are kind of clumping together. Now I've got just about 15 or so seconds to go. Got a lot of turbulence, but not a whole lot of particles are going in there right now. We'll see what we can create with this much mass. We got a 3, 2, 1. Oh, time is up. Okay, so now hopefully you can hear me a little bit better. Let's take a look and see what we have just coalesced into, right? So we were just randomly floating elements and matter up in space, and then we clumped together because of gravity. That's right, anything that has mass has gravity. And so it just took a little bit of a push to clump two of these together, and then more followed. Now I'm going to pour these into our cylinder here, and we're going to use this to measure what we've just become. Notice, we've managed to accumulate enough mass to actually form a gas giant. So this would be a planet kind of like Jupiter or Saturn or even Neptune or Uranus. So we've accumulated enough dust and various gases that we've actually turned into a giant planet. Now, the thing is, we could probably accumulate some more in order to turn into a star. Well, how much different is a gas giant from a star? Turns out I've got just the right visualization for you. I have right here a little diagram of the sun. So the yellow orb is the sun, And if this were to scale, and you zoom in really, really closely, you might find a very small red speck right around there. That tiny red speck, that's actually about the size of Jupiter if the sun were that large. So even though Jupiter is the largest of our planets, it's still a tiny speck compared to our sun. And really, our sun isn't even that large. Our sun is what we call a low mass star, which means that there's stars out there which are many times more massive. There are blue giant stars. There are also red giant stars. So our sun can pale in comparison. And these two big stars here aren't even the biggest stars we know of. So these are actually some really cool ways to visualize this. Now, if that doesn't give you a sense of scale or perspective, then let's think about this for just a little bit. The sun itself makes up 99.7% of the total mass of the solar system. That means that you, myself, the rest of the people here on planet Earth, the rest of the planets in our solar system, and all of the rocks and asteroids and comets that are part of our solar system, we only make up 0.3% the mass of the solar system. So stars are really, really massive. And again, our sun is on the smaller end of the stellar classification spectrum. So let's go ahead and reset this experiment real fast. I want to see if I can't get to accumulate enough matter, enough mass, to actually turn into a star. So we've gone ahead and made a gas giant planet, and I'm going to give myself 30 more seconds and see if I can't clump together enough material to form a star. So I'm going to once again start my timer and see what happens. 3, 2, 1, here we go. All right, so we've got a lot of turbulence going on here, and we've already got a lot of mass kind of clumping together into our collection bowl. And as we have the mass clumping together, you'll notice that it's starting to overflow a little bit here. So maybe I'm doing this a little too well. But of course, let's take a look in just about 5 seconds to see what the result will be. And that's time. So let's take a look right here and observe what we accumulated so far. So we have now almost, actually it's overflowing, so we've got the full bowl filled, and if we pour it into our cylinder here, you notice that already we've accumulated enough mass to become a gas giant, but there's still more mass in there, so we're gonna pour a little bit, and we've gone straight through low mass stars and all the way up to a high mass star. So we've gone from a gas giant, which is actually fairly common throughout the galaxy, to a really uncommon type of star, which are high mass stars. Turns out that stars like the sun, or low mass stars, they make up right about 70% of the stars in the galaxy, with about 30% or so actually being high mass stars. So most of the stars you observe are actually on the lower end of the spectrum. Now that's stellar life, how it begins, right? That's how stars themselves are formed. And let's actually go ahead and take a look at this little tally right here. You'll see again that low mass stars are far more common than high mass stars, but gas giants are even more common than both of these combined. So it's actually a pretty cool visual way to keep track of all of the objects in our galaxy. But let's direct our attention here to this lovely poster, and this will help us better understand how the sun and other stars form. So earlier I mentioned that the sun started kind of like a nebula. It's a giant cloud up in space, and the cloud is made up of different gases, mostly hydrogen, and it starts to clump together because of gravity. And once that happens, you get a tiny protostar, and once you have enough temperature and pressure at the core, that protostar actually ignites into a low mass star. So now we're at the stage where the sun would be, right? And the sun is actually a special type of low mass star. It's what we call a main sequence star. And that means that it's a yellow star that actually is fairly stable, and it actually will go through its life cycle over a period of billions, not millions, but billions of years. So it's expected to continue fusing hydrogen at its core for a few billion years, so no need to mark your calendars. But at the end of that cycle, it will turn into a red giant, so it will swell in size, and eventually it will lose its outer shell, which will leave behind another nebula. So believe it or not, when a star kind of completes its life cycle, it actually resets the space around it so that new stars can be formed. And so far we've followed the low mass star cycle, but if a star is more massive than the sun, say a very high mass star, it actually uses up its fuel supply rather quickly. Instead of billions of years like the sun, it eats through its hydrogen in only millions of years. So in star terms, this star burns up like that. Now eventually it does undergo a tremendous explosion called a supernova, and the shock waves from supernova are actually what provide that turbulence to start clumping the other gases together. So that's pretty cool. It all kind of repeats itself as really like a giant recycling diagram. Now, nebulas are actually really, really cool, and we have another activity planned out. This is something that you could try to do at home. There's a couple of different ways you could do this, and ultimately, we want to end up with some exciting nebulas that we create ourselves. So, a nebula is just a conglomeration of various gases in space, and space is fairly dark, so one of the first ingredients you'll need is just a dark sheet of construction paper. And then we're going to add some elements, which would be the various gases found in a nebula, by using some water-based, washable, non-toxic paint. So we're going to use some of these paints here, and in the end, we're going to throw them into a salad spinner, spin them up, and create some really neat-looking examples of nebulae. So we've got what my friend Catherine labeled here the Sunrise Nebula. It looks very, very awesome. And then I've got this one here, which we've labeled the Hummingbird Nebula, which also looks really, really neat. And again, these are just two very brief examples. And the way we're going to do it is by using a salad spinner. If you don't have a salad spinner, though, that's totally fine. You could put your space, your construction paper, on something like a Lazy Susan, and then simply give that a whirl. And if you don't have a Lazy Susan, I bet you've got some Legos lying around. Some of them might even spin. Be creative. I'm sure you'll get something that's going to make this work. So let's go ahead and actually dive into the activity. In order to create our own nebula, what we're going to do is we're going to start by using our blank canvas, our space here, and we want to add just a few drops of our paint to the very center. I'm going to start by using this very bright yellow color, and I'm going to place only, say, 5 drops. I'm going to actually put this in the spinner first to make my life easy. So we're going to use just about 5 drops, and we're going to place them in the center. I want them to kind of be touching all in the center. There we go. Anywhere between 5 and 10 little drops is the perfect amount. You can, of course, experiment with fewer drops or even adding a few more drops to the mix and see how that will alter the resulting nebula itself. So right now, I've got a pretty interesting pattern going on so far, and I'm going to add just a hint of blue to my nebula. There we go. Let's add some blue color here around the edges. Oh, this looks beautiful already. Perfect. And again, you can choose any colors you wish, and I'm just going to pick green because I like mixing all the colors together. As long as you've got at least 3 colors, your nebula, I'm sure, will look out of this world. And I do apologize for that terrible pun. Not really. I say that with pride. Now, once you've got your nebula on the salad spinner, it's a good idea to kind of give it a little bit of a twist to make sure that those colors are kind of evenly spread out in the middle here. And then comes the fun part. You put it into the actual salad spinner, or be it the Lazy Susan or even your Lego contraption. Make sure everything is secured so you don't get paint all over the walls. I'm sure parents would not enjoy that. And then just give it a push or two. I'm going to start off kind of slow. That way the paint has some time to slowly spread out. And then I'm going to give it a couple more pushes. That's going to help it kind of distribute that paint outwards. And again, the paint is simulating the different types of elements that you would find in a nebula. Those elements came from stars. So all of the oxygen you breathe in, all of the calcium in your bones, that all came from stars. So it's actually really, really neat. We are essentially star stuff. Getting a little excited here. But as soon as this stops spinning, we're going to take a look and see what we have created. So we're going to slow things down a little bit with our handy-dandy brake function. And ooh, you can already tell, look at that. This is pretty nice. Let's take a look at this. We've got some cool, interesting patterns starting to form. And notice how they all kind of radiate from the center where we first added in the paint blobs. That's a perfect example of how nebula spreads out all of those elements around space. Now, what should we name this one? Any thoughts?
They should put their comment below.
I think you guys should leave it in a comment below, and then we'll give it a name. But definitely use your imagination, be creative. That is nebulas, and this is star formation. Now, if you guys have had any questions throughout the comments, definitely feel free to let us know. Type them up right now. We'll be checking the comments periodically, and then I'm the guy who's going to probably end up answering your questions. So if you have any questions, please do let us know. We'll go ahead and give you the answers as soon as we can. Now again, this is part of our whole space series. So we started off with the planetary dance. We also talked about gravity. Today we talked about star formation. Tomorrow, it's going to be an exciting day where we get to talk about constellations, and we're going to wrap things up on Friday with my personal favorite, a behind-the-scenes tour of the Saunders Planetarium. So if you guys don't have any questions right now, we're going to go ahead and say goodbye. Thank you so much for joining us this evening. I hope you've learned a few things. Definitely, stay safe, stay curious, and keep discovering. We'll see you guys next time. Bye-bye.